Yes, Kanna, good morning. I'm audible.
Good morning, sir.
Good morning, Kanna. So, today we shall try to cover complete the entire simple harmonic motion waves. If not in detail, at least the important points we shall discuss today. So that from the next NEET IDJ class, we can go ahead with the numericals on the same topic, right? So, are you ready with notebook, pen? Shall we go ahead? Jyotika, Parkavi, Samesh, ready? Santosh?
Yes, sir.
Very good. Simple harmonic motion. What do you mean by SHM? Simple harmonic motion. A movement of particle in which acceleration of the particle is directly proportional to displacement. This is not the case with most of our physics study. In most of our physics study, say for example, a ball is dropped, acceleration equal to 9.8, a constant. A constant, right? It's a constant. So let us consider car accelerating with 2 meter per second square, decelerating with 2 meter per second square, right? In all these cases, most of the time we assume acceleration is a constant. However, we can take acceleration variable. We can very well solve the problem. For example, acceleration is equal to 2 times t square, suppose, is given function for you. So you can very well do that. It is nothing but dv by dt. Then dv is equal to 2t square into dt. By integrating this, you can very well get the velocity value provided the initial velocity is given. U கொடுத்துருக்கணும். U வந்து 2 meter per second or 0, whatever may be, they should give. அப்படி கொடுத்துருந்தா, you can very well solve it. It's not a big deal, right? It's very simple. Further, you can go for displacement and you can proceed. But this is a special case where acceleration is not a function of time, but the function of displacement. Position. The function of position or displacement. Upon A is directly proportional to y and A is equal to, come on, and A is equal to, we have to put some constant. What constant we are going to put? Omega square times y. Where omega is a constant. Where omega is a constant. What is omega? It's a well-known quantity in physics. Omega is nothing but 2 pi by t, which is nothing but 2 pi nu. This is nothing but 2 pi nu, angular frequency of that particular simple harmonic motion. Angular frequency of that particular simple harmonic motion. Clear now? Shall we go ahead? Shall we go ahead further? Yes. Yes, A is equal to omega square quantum. This is what is called simple harmonic motion. Where else can we understand this simple harmonic motion in any other way? Yes, we can understand. How? Simple harmonic motion is the motion in which you can describe displacement as a function of sinusoidal function. Displacement as a function of sinusoidal function. What do you mean by that? You can, y is equal to minus omega square times, y is equal to, say, sin theta, some k times sin theta, or some k times cos theta, something like that. So, if you can describe your displacement in terms of sine or in terms of cos, then you can clearly call it as simple harmonic motion. You can call it as simple harmonic motion because it will be repeating of its own. Suppose it's sin theta, then it's repeating of its own, you know very well. What is our conclusion today? We are going to arrive at the formula y is equal to, come on, a sin omega t, where omega is equal to theta by t is angular frequency, where omega is equal to theta by t is, come on, theta by t is angular, where omega is equal to theta by t is angular, come on, angular frequency.
Sir, what is the difference between angular frequency and angular velocity?
Both are exactly same. By default in physics, we have been using angular frequency and angular velocity. It is just one and the same. Purida? Just one and the same. By default.
But frequency and velocity are not same, sir.
Of course. But what to do?
Okay.
We have been using time immemorial, the word angular frequency and angular velocity are same. Okay, ma? Nam abdi use pannum.
Yes, sir.
Conventionally, we have been using that. Nothing to worry. So y is equal to A sine, please start copying this, 2 pi by t into t is what is, this is the equation of simple harmonic motion. But in some textbook it is given that y is equal to, even NCRT, A sine omega t plus or minus phi. Not a big deal. The particle starts with some angular position, nothing other than that. So when you substitute t is equal to 0 here, you will get sine phi. You will get sine phi, right? So if it is like this, yes. Now it starts sine omega t, A sine omega t. Suppose it's oscillating like this. Oh, you get a lot of noise, am I right? You could hear the noise? No. Let us wait. Because in the adjacent building there is some repair work is going on, it looks. I am getting noise. Are you not getting noise?
No, sir. Voice is clear, sir.
Okay, excellent. A sin omega t plus phi. Fine. Very good, very good. Y is equal to A sin omega t plus phi is the displacement. But this phi may depend on 30 degree, 40 degree. For example, suppose the simple pendulum is oscillating like this. You start the oscillation at when displacement is 0, then this is the case. Then this is the case. Suppose you begin the oscillation when the displacement is 30 degree or 60 degree somewhere, then it is called that this is 30 degree, this is 60 degree. Okay, I hope you got it. This is displacement. Then come to velocity. Then come to velocity. V is equal to differentiation of displacement A omega cos of omega t. Then acceleration, again the differentiation minus A omega square sine of omega t. This may be called as A is equal to minus omega square times y. A is equal to minus omega square times y. Clear now? Is it clear? This is what is simple harmonic motion. Are you not getting any noise? Any unwanted noise you could hear? The braking noise? No. Good, good, good. I am happy. Okay. So clearly I am going a bit fast. This is A sin omega t. Therefore I can call it as y, where A is this. Then when you consider velocity v here, cos omega t. Velocity is nothing but cos function, right? எப்படி இருக்கும் ரொம்ப clear தெரியும், it will go like this. So cos 0 is 1, sin 0 is 0. Then comes what? Acceleration. Acceleration is nothing but omega square times y but minus. So it's negative function. Come on, Kanna, come on. So this is negative function. What is the amplitude of displacement? This is A. What's the amplitude of velocity? What is the amplitude of velocity? Look at, this is cos function. What's the amplitude? Come on. A omega. What is the amplitude of acceleration? Look at acceleration, sine. What's the amplitude? Come on. A omega square. A omega square. Therefore, sometimes it's very common, they ask the question in entrance, particularly NEET like exams, very easily they ask, if amplitude of velocity or the maximum velocity of a particle under simple harmonic motion is given by set 20. Maximum velocity, what is this? V max. If acceleration maximum of a simple harmonic particle is suppose 10, then what is the frequency? What's the time period? Like that easily they ask question. In this case, A maximum by V maximum is given by, come on, A omega square divided by A omega, which is nothing but omega, which is nothing but 2 pi by t, which is found to be, according to my data, it is 10 by 20, therefore 1 by 2. From this you can very well find the time period of simple harmonic motion. Time, so many seconds you can calculate. So time period of simple harmonic motion you can calculate. So many seconds you can calculate. Got the point? Got it, Kanna?
Sir.
Yes. Some doubt? I am going a bit fast because I have to complete SHM as well as waves on a single day. So I am going a bit fast. If you have any doubt, I can definitely stop and I can discuss with you. I think these are the very fundamental topics. I can go fast. Come on, Kanna.
What is
Come on, Kanna.
you show that for one?
Sure. I am bringing it back. Yes, tell me.
Sir, in this how Vmax prototype and Airmax systems.
I gave you, if at all a numerical.
Okay, sir.
If at all a numerical. Let them give any value, you can find.
Okay.
This is a usual way of asking question, I tell you. In NEET level exams, not JE, but NEET level exam, this is a usual way of asking question. Right. Now, if any particle in which displacement is directly proportional to acceleration, or acceleration is directly proportional to displacement, and acceleration is equal to minus some constant times displacement, that constant is supposed to be omega square whatsoever, that constant is supposed to be omega square, and then it's called simple harmonic motion. What do you mean by simple harmonic motion? The particle should obey sin theta cos theta. The particle should obey SHM, in the sense back and forth oscillation with sinusoidal function, not any other function. Suppose இப்படி இருக்குன்னு வெச்சுக்கோ, sin square theta y is equal to a. No, it is not a simple harmonic motion. இது நம்ம textbookல நிறைய discuss பண்ணிருக்காங்க இத பத்தி. How? Because if anybody draw graph for this, the graph will come like this. This is what is sin square theta graph. It will never go to negative, and it's kind of parabolic, because it is kind of parabolic. I am not claiming it's parabolic. So it goes like this. This is not simple harmonic at all. This is not simple harmonic at all. Like that, any function is not simple harmonic. Only if it is obey sin theta or cos theta. Sometimes even the combination of sin plus cos. Say 2 sin theta plus 3 cos theta. That's also simple harmonic. Right? Right, Kanna? Now we shall go for, in a topic we shall go for energy of a simple harmonic oscillator. We shall go for energy of a simple harmonic oscillator. Energy, எப்படி கண்ணா கண்டுபிடிக்க போறோம்? The easy example I want to have here on the board. This is a simple pendulum which is oscillating like this, right? So this is called displacement. This is called angular displacement, right? Angular displacement. This is the length of the pendulum, m mass of the pendulum. This is mg, right? Now I want to calculate its energy. Let us start with potential energy. What's the definition of potential energy anywhere in physics, in the universe? What's the only one definition of potential energy? Potential energy is negative of work done by, come on, conservative force. Negative of work done by conservative force. Negative of work done by conservative force is what is called? Negative of work done by conservative force is what is called? Come on, Kanna. Negative of work done by conservative force is called potential energy. It's always true.
Potential energy.
Potential energy. It's always true. It's the one and only definition universally. Negative of work done by conservative force. இப்போ நம்மளோட force என்ன இருக்குன்னு பார்த்தா, the force which is pulling this pendulum back, யார் பிடிச்சது பெண்டலத்தை பேக்வர்டில் இருக்கிறா, இங்கேருந்து பிடிச்சி இருக்குது. Who is that for force? That F is equal to simply ma. That F is equal to simply m into a minus omega square times y. So F is equal to minus m omega square times y is the simple force which is pulling the pendulum back, what we call as conservative force. So what is work done by conservative force? Paklama, negative of once again m omega square y into dy is the small work done when you integrate from where to where. நீங்க போட்டுக்கோங்க, இங்க 0, இங்க y. So 0 to y. When you integrate, you get the potential energy to be positive of m omega square y square. Is the ultimate formula for potential energy. So potential energy na inimel I think you kids are very thorough. It's always negative of work done by conservative force. அதான் ரொம்ப சிம்பிள். எங்கே போனாலும் ஒரே டெஃபினேஷன் தான். wherever you go the same definition is same. Right, you got it. இப்போ என்ன தெரியுதுன்னா இதுலேருந்து, here the potential energy is 0. Here the potential energy is maximum. Yes. Therefore, in the case of pendulum like this, when it's oscillating, here the potential energy is maximum, this end potential energy is maximum, the middle potential energy is 0. Potential energy is 0. Right. Now we shall go for kinetic energy. How to calculate kinetic energy? Again, kinetic energy is the only energy in physics which is undisputed and so easy, unchallengeable, simply blindly half mv square for anything and everything. ஒரே ஃபார்முலா தான் இந்த யூனிவர்ஸில் half mv square போட்டால் முடிஞ்சது. இட்ஸ் the easiest energy calculation. Then of m, what is omega square? V is equal to, sorry, V square equal to, நாம் தான் பார்த்தோம், a omega cos of omega t. அல்லது V is also given by omega times square root of a square minus y square. இதில் எது வேணாலும் போட்டுக்கலாம் நீங்கள். ஸோ omega square into a square minus y square. This formula I am choosing. நீங்கள் காசும் போட்டுக்கலாம், ஒன்றும் பிரச்சனை கிடையாது. This is what is called kinetic energy. This is kinetic energy, right? This is kinetic energy. So this is potential energy, this is kinetic energy. The sum of these two energies is called total energy. What is total energy? Of m omega square a square is the total energy. Let us look at the kinetic energy once again. This kinetic energy once again. இங்கே பாருங்க, when the simple pendulum goes to the extreme position, this end and this end, this end and this end, extreme position, what's y? Y equal to a. What's y? Y is equal to a. So if you substitute y is equal to a here, what's your kinetic energy? 0. No doubt the pendulum stops here, because at the edges the pendulum takes turn where the velocity is 0. Naturally kinetic energy is 0. So kinetic energy is maximum at the main position. So whatever may be the position, the total energy is same. What is it? Half m omega square y square, and kinetic energy plus potential energy gives you total energy constant, right? Actually here some noise I am getting around me. You are not hearing that, no?
No, sir.
Excellent, Kanna. That's low frequency noise. Actually some civil breaking work is going on in the neighboring place, next house or next to next house. Some sound I am continuously getting. This mic will detect that. Actually the mic what I am using probably detects low frequency and is removing the low frequency, low pass filter. Okay, fine. Come on. This is total energy.
Sir, in potential energy, how to half cancel?
Integration Kanna, y into dy.
Okay, sir.
Y into dy. Y square by 2. Y power 1 into dy integration is y square by 2, no? You got it.
Yes, sir.
Then when we go for the graph for the energy, be fast because I have to complete the 2 lessons today, so I am going bit fast. Be along with me. Okay. Now if you take the pendulum oscillating like this, suppose this is a pendulum which is oscillating like this. Suppose this is a pendulum which is oscillating like extreme position, mean position. Then when I consider the energy here, this is the total energy of m omega square a square. Then I want to draw kinetic energy. At mean position kinetic energy is maximum and given by this. At the two extreme position the pendulum takes rest, means kinetic energy is 0. So this is my kinetic energy curve. Why I am doing parabolic? Because my function is parabolic. Kinetic energy என்ன formula கொடுத்தோம் நம்ம? What was the formula for kinetic energy? Of m omega square a square minus y square. So it's parabolic, square function comes, therefore it's parabolic. Then when you take potential energy is maximum at the extreme points. At the main position it is 0. It just comes the other way around. It goes like this. So what is potential energy? Potential energy is given by of m omega square y square is the potential energy, right? This is, and then the total energy. So this is the point where kinetic energy is equal to potential energy. If that amplitude of the simple harmonic motion is a, where can you expect this point to be? This, what is the value of this point? What is the distance of this point? Y is equal to, எவ்வளவு இருக்கும் y value for this? What will be y value for this? Come on. இதனோட y value எவ்வளவு கண்ணா இருக்கும்? Simple. A simple pendulum is oscillating with amplitude a. Simple pendulum is oscillating with amplitude a. Say in my case it is 10 centimeter. Suppose it is oscillating with 10 centimeter, where the kinetic energy and potential energies are equal. Where the kinetic energy and potential energies are equal. எங்க கண்ணா? Come on. Where the kinetic energy and
A by root 2, sir.
Yes, a by root 2. Very good, Kanna. A by root 2 is the point where kinetic energy and potential energies are equal. Kinetic energy and potential energies are equal. Got it? Shall I clear it? ரைட். இப்போ எனர்ஜி முடிச்சுட்டு அடுத்து நமக்கு என்ன டாபிக் இருக்குது? நான் என்ன டாபிக் மிஸ் பண்ண ஞாபகப்படுத்துங்க, ப்ளீஸ் டெல் மீ. Now straight away I take you to simple pendulum. Time period, calculation of time period of simple pendulum. So we will go to the other board and we will update something, all the formula what we have done, and then we will come back. Come on. சொல்லுங்க, நாங்கள் என்ன அப்டேட் பண்ண போகிறோம் சொல்லுக்கலாம். இது வரைக்கும் நம்ம என்ன பார்த்துருக்கோம் சொல்லு. வாட் எவர் we have done till now, please tell me what we have seen. A is equal to minus omega square times y. Y is equal to A sin omega t. So A is equal to minus omega square times A sin omega t. Then V is equal to A omega cos of omega t. V is equal to omega times square root of A square minus y square. ஆக்சலரேஷன் முடிஞ்சிடுது. அதுக்கப்புறம் என்ன பார்த்து சொல்லி பார்க்கலாம். F is equal to minus m omega square times y. கைனடிக் எனர்ஜி ஃபார்முலா சொல்லி யாராவது, ஆஃப் m omega square times a square minus y square. பொட்டென்ஷியல் எனர்ஜி ஃபார்முலா சொல்லு, கமான், ஆஃப் m omega square y square. டோட்டல் எனர்ஜி ஃபார்முலா சொல்லு, கமான், ஆஃப் m omega square a square. Any doubt in this? Whatever the formula I have written here, any doubt?
No, sir.
Good. I take you back to simple pendulum. Yes, simple pendulum. Come on. Now, in the case of a simple pendulum, now this is theta, mg, this is also mg, theta, this is mg cos theta, this is mg sin theta. Right? Now tell me, among mg cos theta and mg sin theta, who is the fellow, who is the agency helping you in restoring your simple pendulum back to mean position? Who is that? Out of mg cos theta and mg sin theta, who is the agency, who is the fellow helping you to restore back to the initial position?
mg sin theta.
mg sin theta, that's right. mg sin theta is the force which is helping you to come back. Then what mg cos theta does? What's the duty of mg cos theta? Come on. What mg cos theta does? What's the duty of mg cos theta? See, learning the derivation for CBSE exam, school exam is different. Understanding the subject for the purpose of entrance is slightly different. Come on.
Sir, it helps in tension.
Very good, very good. First, what you have to understand, very good, Kana. First, what you have to understand, simple pendulum when it oscillates, it is executing a part of circular motions. இப்படி சுத்தும்போது இது ஒன்றும் கிடையாது. என்ன பண்ணிட்டு இருக்காரு இவர்னா, இவரால் ஃபுல் சர்க்கிள் இப்படி போக முடியல. He is unable to go with the full circle like this. Therefore, he is dancing in the half circle or quarter circle. எங்கேயோ டான்ஸ் போட்டிருக்காரு இப்படி. If you give sufficient energy, he can go complete round, complete circle, vertical circular motion. He can go, but he is not going. புரியுதா? So முதல்ல first place what you have to understand is simple pendulum oscillation is nothing but a part of, come on, a part of circular motion. First is sector. இது பாருங்க, this is a sector of a circle. அவ்வளோதான், இந்த செக்டருக்குள்ளே ஒரு டான்ஸ் போட்டிருக்காரு. That's it. He is dancing within the sector of the circle. அவ்வளோ, that's it. So clearly, whether the particle goes a complete circle or part circle, he needs the necessary. Why so much of a gap? Whether the particle goes complete circle or a part circle, it needs the necessary ன்னு சொன்னவே அடுத்த வேர்டு வரணும்.
Centripetal force.
Centripetal force. Excellent. It needs necessary centripetal force. Look at the situation, look at the fate. Who is going to give, this is the center O, this is the center O. Who is going to give you necessary centripetal force? Come on. Who is going to give you the necessary centripetal force? Come on.
SHM, sir.
Look at this fellow. Who is this? This fellow. I'll change the color better. Who is going to give you the necessary centripetal force? This fellow, these two fellows together must provide the necessary centripetal force. There is no other go. அப்போ யார் கொடுக்க போறான்னு கண்டா tension minus mg cos theta should give you the necessary centripetal force. Illa sir, they won't give. Your simple pendulum will cut. If they fail to give, if tension minus mg sin t cos theta fail to give you the necessary centripetal force, the moment they fail, probably you guess that this rope is cut, the pendulum goes as per Newton's first law along the straight line motion. It can no more go in circular motion, right? If in the R who is going to come for R? Who is R? Who is the radius of the circle? Look at here. Who is radius of the circle? Who is radius of the circle? L. Apo T minus, come on, T minus mg cos theta provides mv square by L. Got it? Now let us come to the conclusion. Now this is a simple pendulum. Look at here, it is oscillating. At the extreme position, what's the velocity? At the extreme position, this end and this end, what's the velocity? Come on.
0.
0. What is the duty of this fellow? He becomes 0 at the extreme. Therefore, at the extreme positions, say for example here, at the extreme positions, velocity is equal to 0. Therefore, the equation becomes T minus mg cos theta equal to 0. Means T is equal to mg cos theta. So you can take it granted at the extreme position T is equal to mg cos theta. Question கேட்கலாம். They can very well ask the question. A simple pendulum is oscillating with this, that condition கொடுத்துட்டு what is the tension at the extreme position? They can very well ask the question. Clear now? Now, what is cos theta? Cos theta is, if this is the theta, this is opposite, maybe adjacent. Cos sin theta may be approximately taken as y by theta, L. Sin theta may be approximately taken as, displacement is y, the length is L both side, then displacement by L can be taken as sin theta provided theta is very small. I hope you got it. Come to the mean position. This is the mean position. இப்போ என்ன story சொல்ல, what's your story regarding tension here? Come on, tell me what's your story regarding tension here. T minus mg cos theta gives mv square by L. Good. What is theta here at the mean position? What is theta? 0. Cos 0 is kitna? Therefore, what you get is T minus mg mv square by L. The interesting point this velocity is the velocity which is maximum. What's the maximum velocity? What's the maximum velocity? Velocity amplitude kitna yaar? Velocity amplitude एवलो करना है ये ओमेगा. You can substitute very well here. चलो पकड़ा एवलो. Come on, T is equal to T minus mg is equal to m by L times a square omega square. Yes. Based on this, they can give you a question. To solve. புரியுதா? கொடுக்கலாம் question கொடுக்கிறது வாய்ப்பு இருக்கு. Come on, go ahead. Please go ahead. Completed? Shall I go for spring, oscillations of spring?
Sir, how velocity maximum is a square omega square, sir?
The very beginning of the class I gave you now. Yes, look at here. Am I right? You got it?
Yes, sir, yes, sir.
Yes. I hope now it's clear, everything. Shall I take you to oscillations of spring now? Shall I take you to oscillations of spring?
Yes, sir.
Oscillations of a spring. Oscillations of a spring. Suppose it's a spring which is unloaded spring. What is this? Unloaded. No mass is attached to that. Then the spring is naturally called natural spring. And let's say this is a natural spring, unloaded spring, for example. Suppose I load it with some mass. Now what happens? This spring gets elongated by the distance L because you loaded it. Then this becomes mg and this becomes minus k into L. This becomes minus k into L, where k is the spring constant. Because what is the spring force? K into x. K into x. Just for convenience, because later I am going to take x or y, whatever may be. So I take it. So what happens? Now, after loading the spring gets elongated but stays there. Why? Because it is already got elongated by the distance L, but it could not go back because there is a permanent load of mg. There is a permanent load of mg. To balance that, you need k into L. Now, if you elongate it further beyond this k into L, இதுக்கும் மேலே x தூரம் பிடிச்சின்னு இருக்கிறேன். அப்போ what's your total elongation right from the beginning? What's your total elongation right from the zero load? Already elongated by L, now it got an additional distance of L plus x. Now the spring has to apply the backward force of k times L plus x. So the spring should apply the backward force of k times L plus x. Got the point? K times L plus x. So what is your net force on your load now? The net force on your load now is given by, this is mg, this is minus k times L plus x. So x is the additional displacement that you gave. Just like say simple pendulum simple pendulum is at the middle position. Now mg, tension, balance. Tension equal to mg because it's the main position. இப்போ நாம தான் இதை ஆசிலேட் பண்ணணும். You have to displace it. You have to, third party has to pull it and displace it. Otherwise simple pendulum won't oscillate. அதே மாதிரி now the spring, here it is in equilibrium position. mg is equal to k into L magnitude wise. It is elongated position. But if you want to oscillate, you have to oscillate further. That further at displacement, what you give x for oscillating is what is called the displacement of the pendulum. Yes. Now what's the net force? Now the F net is given by minus k into L plus x, say plus mg. நீங்கள் அது எது வேணாலும் plus minus எடுத்துக்கோங்க. I have taken this as plus and this is minus. அவ்வளவுதான். நீங்கள் ஒன்று உள்டா கூட எடுத்துக்கலாம், ஒன்றும் பிரச்சனை கிடையாது. Yes, now it's a case. So k into L gets cancelled with mg because you know k into L equal to mg magnitude wise, but they are in opposite direction. Therefore k into x is the net force. So clearly the force is directly proportional to x. So what is force? Ma is equal to minus k into x. So A is equal to minus k by m times x. A is equal to minus k by negative of k by m times x. K by m times x. Where, got the point? Where k by m is nothing but omega square. K by m is nothing but omega square. Shall we go ahead? Please copy it. Don't hesitate to copy. Don't be lazy in copying it. You can copy it 1,000 times, no problem. You should get imbibed with you. சும்மா எழுதிக்கிட்டே இரு. ஃபிசிக்ஸ் பொறுத்த வரைக்கும் சும்மா ஃபார்முலா எழுதி நான் நடத்தும் போது சும்மா உட்காராது. அப்புறம் எடுத்து எழுதிக்கிட்டே இரு. கீப் ரைட்டிங். சம் நோட் புக் ஆர் அதர், ரஃப் நோட் புக் ஆர் அதர். நான் என்னென்ன போடணும் போர்டில் போட்டுக்கிட்டே இரு. தென் only you can score full mark in physics, particularly NEET and IIT. Okay, Kanna. So A is equal to minus omega square times y. Yes, displacement gone. A is gone, negative is gone. Yes, we beautifully got the answer. Therefore omega is equal to square root of k by m, means 2 pi by t is equal to square root of k by m, means t is equal to 2 pi into square root of m by k. T is equal to 2 pi into square root of m by k, where m is mass attached. Where m is mass attached to the spring. M is mass attached to the spring. நீங்கள் எவ்வளோ மாஸ் அட்டென்ட் பண்ணீங்க, whether 500 grams, 600 grams, 1 kg, 10 kg, whatever you want. That's your choice. Depends on the case. So we found, last time we found time period of simple pendulum. என்ன கண்டுபிடிச்ச simple pendulum time period போட்டோமா இல்லை, simple pendulum time period போடல. We'll do that.
Sir,
Yes, Kanna.
sir, if mg is equal to minus a into n plus x means why L is not getting cancelled?
Sorry, I'm not getting it. Sorry, come on.
Sir, mg is equal to minus k into n plus x means why L alone is getting cancelled?
Because already we proved. Look at here. Mg is equal to k into L. Already we proved. In the second part of the discussion, we have already proved. Then I'm already proved பண்ணிட்டோமே கண்ணா.
Yes, sir.
Already we proved it. K into L equal to mg. We have already proved it. Because when you put mg, the spring is getting elongated by L, means it's getting balanced, means K into L equal to mg. புரியுதா இல்லையா?
Yes, sir.
T is equal to 2 pi into square root of m by k. Right, Kanna? Completed, I believe. Completed, I hope. Am I right?
Yes, sir. Yes, sir.
Now we should go for yes. Now we should go for once again simple pendulum. What I missed in simple pendulum was the time period. Yes, I missed it actually. Yes, this is theta, suppose. This is the displacement y. This is L. the particle is here, mg. Already I told you this is mg sin theta and this is mg cos theta. This is tension, even this is tension. Okay, fine. Now, what is the restoring force? F is equal to ma is equal to mg sin theta. So, A is equal to G sin theta. Sin theta can be approximately written as A by L. So, A by L. So, it is an approximate value. A is equal to minus G times A by L. இங்க என்ன பிரச்சனைனா, this is A y by L, sorry, fine, y by L, because this in this sector theta is approximately sin theta is approximately y by L, so y is equal to minus, come on, y is equal to y வேண்டாமே a வில் எடுத்துக்கலாம், a is equal to minus G by L times y. A is equal to minus omega square times y. You can get the answer. Omega is equal to this. So, omega is equal to square root of G by L, means T is equal to 2 pi into square root of L by G. Into square root of L by G. Please take your notebook and copy it. Some kids are watching on YouTube also. They also can do the same thing. Please take your notebook. Just keep jotting down the points. I want to take you to the other screen, complete the update, and then we'll come back. Shall we go? Yes, come on here. Come on, what are the formula we have to update? Come on, help me. Simple pendulum. T is equal to 2 pi into square root of L by G. Right. Where in a simple pendulum the idea we found that T minus mg cos theta provides the necessary mv squared by L. This is the case of simple pendulum. Then spring. Come on, T is equal to 2 pi into square root of m by k. Have you learned anything other than this? Am I right? No affirmative answer, no one is answering. Come on. Shall I clear this and go to next? Next page poilama.
Yes, sir. Yes, sir.
Yes. Yes, we can go for next page. Next simple harmonic motion, pendulum. Now we have to have a comparative analysis between pendulum and spring. That's most important. Spring, pendulum. T is equal to 2 pi into square root of L by G. T is equal to 2 pi into square root of m by k. L by G, m by k. Right. When you take the simple pendulum from one place into another place, say you go from equator to pole, you go from earth to moon, you take inside the swimming pool, you go to elevator which is accelerating, when the aeroplane is taking off, right? In all these cases, or when the aeroplane is landing, in all these cases, acceleration slightly changes, right? When the aeroplane is taking off, we feel more heavy. When the aeroplane is coming down, we feel very light, all this. So in all these cases, the effective G value changes, net G value changes for us. Of a simple pendulum, time period will also change. So when you go from one, if G changes, time period of simple pendulum changes, please take note. But if G changes, time period of spring does not change, because it does not depend on G at all, it does not depend on acceleration at all. Therefore, whether you do the spring pendulum, spring oscillations in a room or in a lift or in an aeroplane or inside the swimming pool or in the moon, the answer is supposed to be, the result of time period or frequency is supposed to be the same. So supposed to be the same. That's the difference between these two. On the other hand, suppose you are using a bigger mass in simple pendulum. Now I am using a very tiny steel ball here in the simple pendulum. Suppose I am using bigger mass, bigger than this. Even then, it's bigger than this. Again, my time period is same in the case of simple pendulum, because simple pendulum does not depend on mass of the pendulum. But in the case of spring, it does depend on, mass of the,
Acceleration due to gravity.
no, it depends on mass attached. So in the spring, it depends whether you attach 1 kg or 2 kg, makes a lot of difference in the time period, because it's after all depend on mass. Whereas whether the simple pendulum, in the case of simple pendulum, whether you have 1 kg or 2 kg makes no difference. For 1 kg bob, the same result. Even for 2 kg bob, the same result. Got the point? Got it?
Yes, sir.
So effective gravity plays a role, effective gravity does not play a role, Accordingly, we have to change the formula. Come on, Kana, some doubt, come on.
In simple pendulum, if the length is same, the time will be same for anyone.
Only L is the difference. Yes, come on. If the length is same, whatever may be the mass, the time period is same. You are right.
Okay.
Whatever may be the mass, the time period is same. Any other doubt, Kana? Any other doubt?
No, sir.
No. Suppose a simple pendulum is oscillating inside the swimming pool in water. Say why water? Some liquid. How will the time period change? Come on. How will the time period change? Yes. Come on. Paklama. When a bob is immersed in water, this is rho into G. This is sigma into G, where sigma is the, V rho G is the weight downward, V sigma G is the weight upward, up thrust. Therefore, V rho G minus V sigma G is equal to V rho G dash. We cancel. Therefore, G dash equal to rho minus sigma by rho into G is what is G dash. What is G dash? The effective gravity is nothing but rho minus sigma divided by rho into G. Clear now? Above, in the case of suppose a simple pendulum is immersed in swimming pool, this has to replace this place. Up and over time period T is equal to 2 pi into square root of L by that formula, rho minus sigma by rho into G. So what you get is 2 pi into square root of rho divided by rho minus sigma L by G. Clear now? Yes. So almost everything is over. Now springs in series, springs in parallel. யாராவது டக்கு ஆன்சர் சொல்றீங்களா? வேகமா போயிடலாம். Springs in series and springs in parallel. Springs K1, K2. Springs in parallel. What's the K value? Come on, K1, K2. In parallel, it is simply K1 plus,
K1 plus K2.
yes, equal to K. In series combination, 1 by K is equal to 1 by K1 plus 1 by K2 is the result. Or simply, if there are only two springs, you can call it as K1, K2 divided by K1 plus K2. K1, K2 divided by K1 plus K2. So, in which case time period is going to increase? In which case time period is going to increase? In which case time period is going to increase? In series or parallel? Two springs are there.
Parallel.
In parallel combination, yes, K will increase. K will increase. Time period will decrease. Apo, when you connect two springs in parallel, parallel, they oscillate faster. They oscillate faster than the normal. Means time period is going faster, means time period is less. So once again, because you get net effective force is more. So force becomes more. When force becomes more, they oscillate faster. Very easy, logical. When they oscillate faster, time period should decrease. Means K is increased. Of course, K is increased. But when you connect them in series, you can understand it may take longer time. So this fellow is going 5 centimeter, the other fellow is going 6 centimeter. Now the body has to travel 11 centimeter altogether. So will it take more time or less time?
More time.
More time, yes. Time period will be more, means K is less. Of course, it has got decreased. In parallel combination, it got decreased. If the effective value of this value will be less than K1, K2. The effective value of K is supposed to be less than K1, K2 as per our calculation. K1, K2 by K1 plus K2 if you calculate. Got it? Logically, you need not go purely with physics. In our day-to-day experience, we can understand. Right, Kana? Shall I go ahead? Shall I go ahead? Polama, further.
Sir, 1 minute, can you show that K1
Sure,
K2?
sure, Kana. I'll bring it back, don't worry. Yes. I can go for proof also, but not now. For your NEET student, the proof all or a JE student need proof all. We can go ahead with it. Shall we go ahead? You don't get any noise, no? Or mild noise is there, some background noise is there times. Confirm me so that I can tune my device properly.
Sir, no sounds.
No sound. Because YouTube student Varun Raghav has written me that he is getting kind of mild noise, but the delivery goes from the same system only. I don't know how. Okay, let's check.
There's small only, sir.
Very small, huh? Some negligible noise.
Yes, sir.
Because in the neighboring house, some breaking work is going on. Okay, fine. Actually, after starting my class, first 5 minutes, I thought I can close because the noise is so bad here. But luckily, our mic does good job. It is cutting all the low frequency. You know very well, noise is a low frequency. Are you aware of that? Are you aware of the fact that noise is a low frequency? Yes or no?
No, sir.
No.
Nice, sir.
Any noise is a low frequency or high frequency?
Sir, that depends on the sounds.
No, no. High frequency is supposed to be music. Nobody can hate it. Low frequency is supposed to be noise. Everybody will hate it. That's the point, right? So any low frequency, suppose tabla, morning prayer, drums, dum dum dum, they are making. That's a low frequency, maybe around 200 hertz, 300 hertz, something like that. That's not very pleasant. Okay, some breaking noise, etc., etc., is not very pleasant. That is unpleasant, which is supposed to be very low frequency, like below 500 hertz or something. Very below. Yes, what I'm saying is correct. So our audible frequency, which you can hear, is something between 2000 to 4000. I mean, sorry, human voice frequency. By mistake, I said audible. Human voice frequency is 2000 to 4000, whereas audible is 20 to 20,000 hertz. You know. So if anything goes more than 5000, which is supposed to be pleasant, there's a newborn child. The voice is somewhere around 6000 hertz or so, 7000 hertz or so. That's always pleasant voice, right? Kid's voice, maybe 5000 hertz, something like that. So as we grow, our vocal cord becomes very tough, like us. So it becomes frequency decreases, right? Veena, guitar, all those melodious sounds, say even the harmonia, etc., they come around 10,000 hertz or 11,000 hertz, something like that. They're supposed to be melodious and sweet. So our mics, good mics, high quality mics are designed in such a way, they don't pick up all the sound around you. They are designed in such a way, the spectrum will go like this. The cutoff frequency, something like 500 hertz or something. So that won't pick up. See, mics are not, all the mics are same. Some mics are designed for audience pickup, some mics are designed for speaker pickup. So those mics are pick up only the voice, human voice frequency. They don't pick up musical voice. Say for example, this mic is it is called a public audio mic. So this won't help you for orchestra. If a singer uses this, that may not work well because this may not pick up the musical tones. Got the point? It won't pick up the musical tones. In a musical tones, low frequency or high frequency or it won't pick up that. It will pick up only that human voice. That's what it pick up on. It's like that. Okay, come on. Now go to any topic. Next day. I think we are almost all set to start. Waves. What do you mean by a wave? A wave is சொன்னவனே எல்லாரும் நமக்கு தெரியும். இதான் wave. இதான் சார் wave. அவ்வளவுதான் சார் போங்க. That's a wave. So this is crest. This is trough. Crest and trough. So this is what wave? Transverse wave. This is nothing but transverse wave. Transverse wave. This is nothing but longitudinal wave. Longitudinal wave. Come on. Longitudinal wave எப்படி discuss பண்ண போறோம்? How the longitudinal wave travels? If molecules of the medium vibrate parallel to the propagation. இதுதான் propagation. Propagation இப்படி போயிட்டு இருக்கு. இதுதான் propagation. This is the propagation. This is the propagation, right? So if molecules of the medium vibrate in the direction of propagation, then it's called what? Longitudinal. If molecules of the medium vibrate perpendicular to propagation, then it's called transverse. இப்போ பாருங்க நான் செஞ்சு காட்டுறேன் பாருங்க கவனி. Now this is the case. Now I oscillate like this. So now my fingers are oscillating, my hand is oscillating perpendicular to wave propagation or parallel to wave propagation? Then it is transverse. What you see is transverse, right? Suppose I oscillate like this. What wave it is? Longitudinal. So simple it is. Longitudinal wave. So in longitudinal wave, because it's a short spring, I may not be able to show you, but if I have a long slicky, then I can show you that at some places spring is getting compressed, at some places spring is getting bit elongated, rarefied, and all those. So in this area it is compressed, here it is rarefied, again it is compressed, here again it is rarefied. So this is called compression and rarefaction. Compression and rarefaction. Compression and rarefaction. So spring is, say in the case of when the molecules of the medium vibrate parallel to the direction of propagation, at some regions the molecules are getting more closer, at some region the molecules become further, like slicky, spring becomes compressed, and so those areas are called compression and rarefaction. So compression can be almost compared to crest. Rarefaction may be almost compared to trough, but they are not same, but its comparison will be easy. Yes, now wavelength. What is the wavelength? What is the wavelength? Wavelength is the distance comprising one compression, one rarefaction, one crest, one trough is called wavelength. It's called wavelength. It's called wavelength. Now, what's the speed of the wave? What is the speed of the wave? Velocity of wave. Wave velocity. Wave velocity. Speed of the wave. Wave velocity. அதுக்கு என்ன kind of formula? Wave velocity க்கு ஏதாவது formula வச்சிருக்கீங்களா? Come on, tell me. Any formula you have for wave velocity? Now, these are the particles which are dancing like this. These are the particles which are dancing like this. These are the particles which are dancing like this. Come on. Then the molecules are undergoing simple harmonic motion. You catch hold any molecule here. Catch hold any molecule here. What is its formula? It is simple harmonic motion. Another formula varum, y is equal to, what's the formula for this? Come on, y is equal to a sin omega t. Formula for this particle at the origin is a is equal to y is equal to a sin omega t. No, now you want to take a particle here. Look at carefully, which is at the distance x from the center origin. Now for this particle, what equation you want to attach? You want to attach the equation for this particle. Come on, for this particle, y is equal to a sin omega t minus phi. A sin omega t minus phi. Right now, a sin omega t minus phi. Y is equal to a sin omega t, right, minus phi. What's the value of phi? By what angle it changes? Had you displaced by the angle lambda, the phase change would have been 2 pi. Had you displaced by 2 lambda, come on, 2 lambda, your phase change would have been 4 pi. Therefore, 2 pi belongs to lambda, right? 2 pi belongs to lambda, then x belongs to phi. And in the particle, x is the distance, the corresponding angle is phi. The corresponding angle is phi. So therefore, when you take the ratio, you get 2 pi x by lambda. You got it. From this, you got 2 pi x by lambda is the value of phi. Is the value of phi. You substitute. So this is the equation of any plane progressive wave. It's the equation of any plane progressive wave. Then what's the equation of any plane progressive wave? Y is equal to a sin omega by என்ன போட போறோம் 2 pi by t into t minus 2 pi x by lambda. This is equation of any plane progressive wave. Equation of any plane progressive wave. Got it? Equation of any plane progressive wave. Update பண்ணிட்டு வந்துலாமா போர்டில்? நம்ம கடைசி என்ன பார்த்தோம்? SHMல என்ன பார்த்தோம் கடைசியா? ஸ்ப்ரிங் சீரிஸ் parallel பார்த்தோம் இல்லையா? கரெக்ட் தானே? எஸ். ரைட், அதுக்கப்புறம் என்ன பார்த்தோம்? வேவ்ஸ் ஆரம்பிச்சிட்டோம். right? It's a
Sir,
yes, Kanna. Yes, yes.
sir, in our school for the simple pendulum, sir,
Hmm.
they told time period is equal to 2 pi into root of displacement by acceleration.
அதான் y தான் டிஸ்பிளேஸ்மெண்ட், g தான் acceleration. சரியா போச்சு, என்ன போச்சு? See, look at now this pen I am throwing like this. What's the acceleration? G. I throw like this. What's the acceleration? G. I throw like this. What's the acceleration? G. So 2 pi into square root of L by G, right? Or you can call it as they are giving y by g, huh? They are giving displacement by acceleration, right?
Y by A, sir.
Y by a. Y is the
Yes.
okay. Y by a. இவங்க y by a ன்னு சொல்கிறாங்க. Y by a is okay. Displacement by acceleration is fine. I'll show you. போடலாம், அப்படி கூட போடலாம், ஒன்றும் தப்பு ஒன்றும் கிடையாது. Nothing wrong. I'll show you. Come this side. I'll show you.
Okay.
ஓ, உங்கள் வேவ்ஸில் இருக்குமா? இங்கே போய் முடிச்சுட்டு வந்துடலாமே. கமான் சொல்லுக்கண்ணா, உனக்கு என்ன வேணும்? t is equal to 2 pi into square root of y by a ன்னு சொல்கிறாங்களா? ரொம்ப சிம்பிள்மா. a is equal to minus omega square times y, right? இது அப்படியே அவங்க எடுத்துக்கிட்டாங்க. ஸோ ரைட், இது அப்படியே எடுத்துக்கிட்டாங்க. வாட் இஸ் திஸ்? ஒமேகா இஸ் ஈக்குவல் டு ஸ்கொயர் ரூட் ஆஃப், நீங்களே சொல்லுங்கள், a by y, 2 pi by t is equal to square root of a by y. Therefore, right, so t is equal to 2 pi into square root of y by a. So they took the very fundamental formula. ஆனால் நாம் என்ன பண்ணோம்னா, this is not a fair idea. ஏன் fair idea கிடையாதுன்னா, this is not a good formula. Why it is not a good formula, I tell you. When a simple pendulum is oscillating, but this is a correct formula, but not a good idea. ஏன்னா இப்படி சிம்பிள் பெண்டில் ஆசிலேட் ஆகிட்டு இருக்கும்போது திஸ் ஒய் மேபி 10 சென்டிமீட்டர், இன்னும் கொஞ்சம் நேரத்துக்கு அப்புறம் இது 4 சென்டிமீட்டர், அப்புறம் இது 2 சென்டிமீட்டர். அப்போது திஸ் ஒய் இஸ் எ வேரியபிள் ஆர் கான்ஸ்டன்ட்? யூ டெல் மீ. வேரியபிள். கம் டு ஏ. வாட் இஸ் ஏ? யூ நோ வெரி வெல். இதுதான் ரெஸ்டோரிங் ஃபோர்ஸ். எஃப் இஸ் ஈக்குவல் டு ஜி சைன் தீட்டா, ரைட்? எம்ஜி சைன் தீட்டா ஈக்குவல் டு எம்இ. அப்போ mm கேன்சல். வாட்ஸ் த ஆக்சலரேஷன்? a இஸ் சிம்பிளி g sin theta. இப்போ சொல்லு, இங்கேருந்து இங்கே வரும்போது இப்படி திரும்பி வந்துகிட்டு இருக்கு சிம்பிள் பெண்டிலம். இட்ஸ் கமிங் ஆல் த வே திஸ் சைட். ஸோ வெதர் திஸ் a acceleration is a variable or constant?
Variables.
Again it's variable. அப்போது இட்ஸ் நாட் ஃபேர் டு ஹாவ் அ ஃபிசிக்ஸ் ஈக்குவேஷன் வித் வேரியபிள்ஸ். நம்மளோட ஃபிசிக்ஸோட என்டையர் புக்கே நம்மளுடைய அப்ஜெக்டிவே என்னென்னா, we want to give formula in terms of constants. இங்கே பாருங்கள், எதுவுமே நம்ம கான்ஸ்டண்ட்டாக தான் யூஸ் பண்ணுவோம். பாரு, m is a constant, k is a constant, g is a constant, l is a constant. இப்படி தான் டெரைவ் பண்ணணும். தட்ஸ் அவர் அப்ஜெக்டிவ் ஆஃப் எனி டெரிவேஷன் இன் ஃபிசிக்ஸ். புரியுதா? ஒரு பெரிய டெரிவேஷன் போடும், ஃபைனலாக ஒரு ஃபார்முலா வரும். வி ப்ரிஃபர் டு ஹேவ் தட் ஃபார்முலா டு பி இண்டிபெண்டன்ட் ஆஃப் வேரியபிள்ஸ். சாரி, எஸ், இண்டிபெண்டன்ட் ஆஃப் வேரியபிள்ஸ். இட்ஸ் சப்போஸ் டு பி கான்ஸ்டன்ட் டிபெண்டன்ட். அதுதான் நம்மளோட அப்ஜெக்டிவே. இப்போ இதில் ரெண்டுத்தையும் வேரியபிளை வச்சுட்டு நம்ம என்ன பண்ண போகிறோம்? அஃப்கோர்ஸ் நாளைக்கு அப்படி ஒரு கொஷன் கேட்டால் ப்ராப்ளி திஸ் மே பி யூஸ்ஃபுல். அப்போ நீங்கள் டைரெக்டாக இதையே யூஸ் பண்ணிட்டு போகலாம். காட் த பாயிண்ட்?
Yes, sir.
No, but I cannot claim that the given equation is wrong. அவங்க கொடுத்தது தப்புன்னு நான் சொல்ல மாட்டேன். But that's not correct way. That's just variable. It's not ideal to have formula variables in formula.
Okay, sir.
So, what is first of all wave now? What is first of all wave now? What do you mean by wave now? Sriram, good. Sriram is here. Sriram is asking anything new? No, it is simply brush up of SHM and waves. Simply brush up of SHM's wave. Okay, come on. Now we'll continue. Now when about the wave, can any of you explain me after I arrived at the equation for wave? What equation for arrived panirkom? Come on. What is the equation that I have arrived at for a wave? Come on, what is that? Y is equal to a sine 2 pi t by t minus x by lambda. This is a formula we have arrived at, right? T by t minus x by lambda. This is a formula we have arrived at as of now. Yes, 2 pi. Yes. Now in the formula, we want to go for velocity. Come on, velocity enna pannalam yara sollu paakalam. Dy by dt. Come on, be fast. Dy by dt. Come on. A omega cos of 2 pi இது எடுத்துக்கிறேன். டிஃபரன்ஷியேஷனுக்கு ரொம்ப ஈஸியாக இருக்கும், உங்களுக்கும் ஈஸியாக இருக்கும். Come on, a omega cos of omega t minus phi is the velocity. Is the velocity equation. நான் ஏற்கனவே SHM ல பண்ண அதே ஸ்டோரி தான். நான் எதுக்காக இது மறுபடியும் எழுதுறேன்னு கண்டா, now I want to tell you that this velocity is different from the wave velocity. இந்த wave velocity வந்து இப்படி போயிட்டு இருக்கு. This is the wave velocity. Velocity of a wave, whereas this is velocity of the particle. This is velocity of the particle of a particle. Velocity of a particle, right? So this is governed by velocity of the particle. Now my question for you, what is the velocity of wave? Another idea vechirkingla velocity of wave eppadi podunu edha idea vechirkingla? Come on. Ipo na pesren, because I speak, the oxygen nitrogen molecules in the atmosphere oscillate with simple harmonically. Those oscillations are governed by this equation. This velocity equation governs that, right? This velocity equation governs that. But my question now is, my sound spreads in this room with the speed of 350 meter per second, 350 meter per second. And the speed ku edavadhu formula vechirkingla for 350 meter per second? Do you have any formula? Come on. Come on, wave velocity ku edavadhu idea vechirkingla? Yes or no? Come on. Do you have any idea for wave velocity? Yes or no? Come on. சொல்லுங்கண்ணே, wave velocity க்கு ஐடியா வச்சிருக்கீங்களா? Yes. Wave velocity. No. String. What is the velocity of wave in a string? The செஞ்சு காட்டினால இதான். Now the wave travels with the velocity. What's the wave velocity? Formula for wave velocity. Come on. V is equal to square root of t by m. யாராவது எனக்கு t என்னன்னு சொல்லி பார்க்கலாம்? Tension. M is m ஆவது யாராவது எனக்கு சொல்லி பார்க்கலாம்? What is m? Mass per unit length. Mass per unit length. Yes, that's what is m. String. Velocity v is equal to square root of t by m, and m is mass per unit length. This is the speed of sound. Come on, speed of any wave in where? Speed of any wave in. Come on, can I please? Speed of any wave in a string, wire, rope. Illadhukku idhe formula. Right. Come to gas. Longitudinal wave. What is the speed of longitudinal wave in gas? That's what I am talking about now. Sound is simply given by v is equal to square root of, come on, bulk modulus by rho. Square root of bulk modulus by rho, where b is bulk modulus. Do the gas have bulk modulus? Yes or no? Do the gases have bulk modulus? Yes or no?
Yes, sir.
See, there are three types of modulus: Young's modulus, bulk modulus, rigidity modulus. Which modulus the gases do not have? Which modulus the gases do not have? Please, come on, be fast. Out of Young's modulus, bulk modulus and rigidity modulus, which modulus the gases do not have? Come on. Which modulus the gases do not have? Come on.
Young's modulus, sir.
Young's modulus as well as rigidity modulus. As well as rigidity modulus. What is rigidity modulus? If you shear a body, see the one I'm rotate pandra. See, I'm rotating. I'm trying to rotate it. I hope you can see that. It will come back. This is what is rigidity. When I rotate, it comes back. This is what is rigidity, turning, right? If I pull it with a rubber band like, it tries to go back. That's what is Young's modulus. Bulk modulus, if I compress all together, it tries to come back. So gases have got that property. If you compress, they try to come back. If you leave it, they want to expand. But they don't have rigidity, they don't have Young's, they don't have. But bulk modulus they do have. They do have. What is the bulk modulus formula? Help பண்ணுங்க. What's the bulk modulus formula? What's the formula for bulk modulus? தெரியுமே, force per unit area. Stress by strain, change in volume by மறந்து போச்சோ எல்லாம் அமைதியாக இருக்கேன். Young's modulus மறந்து போச்சோ. Young's modulus is given by force per unit area, stress by strain, change in length by original length. You remember this or not?
Yes, sir.
Stress by strain. Similarly, this is force per unit area by change in length. But bulk modulus என்ன வரும்னா, the force per unit area is removed. We call it as change in pressure. We call it as change in pressure. Change in pressure. Therefore, if you increase the pressure, look at, if you increase the pressure, this volume will decrease and vice versa. If you increase the pressure, volume will decrease and vice versa. And vice versa. Got the point? Got it, Kannan?
Yes, sir.
Yes. இப்போ சொல்லுங்க, bulk modulus of gas, say atmospheric air க்கு என்ன பண்ண போறோம்? What is the idea you are having for bulk modulus of atmospheric air? Now we need the help of thermodynamics. Now when sound moves in air, atmosphere, pressure changes, volume changes. Pressure changes, volume changes. We just enter into thermodynamics. Change in pressure, change in volume. Parameters change. Thermodynamical parameters change. Thermodynamical variables change. When pressure changes, volume changes, our first question, is it isothermal, adiabatic, isochoric, isobaric? Which it is? Is it isothermal, adiabatic, isochoric, isobaric? Which it is? It's the big question. So Newton assumed that it is isothermal. His argument is, when I am talking in the room is not getting heated up, right? So it is isothermal process, he assumed. If it is really isothermal process, what's the formula for isothermal process? PV is equal to, come on, PV is equal to constant. Differentiation, PdV plus VdP equal to 0. So I am interested in, right, PdV by V equal to minus dP. Change the formula. So P is equal to minus dP divided by dV by V. Oh, this is what we are expecting here. This is what we are expecting. The same, exactly same I got. So bulk modulus is nothing but pressure. So what's the bulk modulus of air now? In the room na pesittu irukken. Air room la, what's the bulk modulus of air? Come on. The bulk modulus of air is simply given by 1.01 into 10 power 5 Pascal. Because which is same as the atmospheric pressure. Which is same as that. Atmospheric pressure the Young's modulus. Sorry, bulk modulus. Bulk modulus the atmospheric pressure. Got it or not? Yes. But by chance, if you substitute this here, you get the velocity of the sound to be. You get the velocity of the sound to be. ஒரு சமயம் நீங்கள் இதை சப்ஸ்டியூட் பண்ணிங்கன்னா, you are getting the velocity of sound to be somewhere around 311 meter per second, which is not exactly working. Sorry, Kanna, 280. By mistake I said 280. நீங்கள் சப்ஸ்டியூட் பண்ணி பார்த்தீங்கன்னா தெரியும். You will get exactly value. You know the rho density of water, rho air, you know. Density of air is around 1.2. Very, very close to 1.2. So if you substitute, you will definitely get. இந்த ஆன்சர் வரும் உங்களுக்கு. சும்மா கால்குலேட்டர் தான் போட்டுக்கோ. You will get around 280 or 281, something like that. But this 281 we are not happy because we know pretty well the velocity of sound is around 350 or 330 meter per second. 330 at 0 degree Celsius, 350 at 30 degree Celsius. This is the velocity of sound. So, Newton idea is not correct. What idea he made? Please come back. What idea he gave you? Newton, what idea he gave you? According to him, propagation of sound is an
isothermal.
So that is fundamentally wrong. That is fundamentally wrong. Then what process it is? Then Laplace. He assumed that it's an adiabatic process. Straight away he gone diametrically opposite side. According to him, propagation of sound in atmosphere is an adiabatic process.